Solve the given Bernoulli differential equation. dy over dx plus y to the power of 3 divided by 2x multiplied by e to the power of negative 2x is equal to y. So our first step is to write our equation in this format. So we're going to have dy over dx minus y is equal to negative y to the power of 3 divided by 2x e to the power of negative 2x. So now we can set our p of x equal to negative 1 and our q of x equal to e to the power of negative 2x over 2x, and our n is going to equal 3. So for our second step, we are going to set our v equal to y to the power of 1 minus our n, which is 3. So we're going to get y to the power of negative 2. So now we're going to rewrite this in terms of our y. So our y is going to equal v to the power of negative 1/2. And next we're going to take the derivative. So we're going to get dy over dx is equal to negative 1 over 2 v to the power of negative 3 over 2 dv over dx. So next we're going to take this equation, which is dy over dx, and substitute it into our dy over dx over here. So we're going to get negative 1/2 v to the power of negative 1, or negative 3 to the power of, v to the power of negative 3 divided by 2 dv over dx minus 1 over v to the power of 1/2. So we're substituting our v as v to the power of negative 1/2, which is equal to negative e to the power of negative 2x divided by 2x. And again, we're going to do the same thing with this y. So we're going to get v to the power of negative 3 divided by 2. So now this is all going to simplify into dv over dx plus 2v is equal to e to the power of negative 2x divided by x. So now if we look at this equation carefully, it's in the format of dv over dx plus p of x times v is equal to q of x. This is our linear first order differential equation. So we're going to solve this differential equation using our integrating factor. So we're going to set our p of x equal to 2, and our q of x is e to the power of negative 2x over x, and therefore our integrating factor is going to be e to the power of the integral of 2 dx, which just equals e to the power of 2x. So now we're going to take our integrating factor and we are going to multiply all the terms of our equation by e to the power of 2x. So we're going to get e to the power of 2x multiplied by dv over dx plus 2 times v is equal to e to the power of 2x multiplied by e negative 2x over x. And because this is just we can simplify this first. So we're going to get e to the power of 2x dv over dx plus 2 times b e to the power of 2x, which is equal to 1 over x. And because this is just a simple, it's just multiplying, so if we set our u equal to e to the power of 2x, then we have dv over dx plus our v times by our du over dx. So we can simplify this and write this as d over dx times our u, which we can set as e to the power of 2x multiplied by our v, which is just v, which is equal to 1 over x. And now we can take the derivative of this. We can move our d over dx to the right side, and that'll be a simple integral, and we'll just get e to the power of 2x times v is equal to ln absolute value x plus c. And now we can substitute our v back as y to the power of -2. And we can write our final equation in terms of y. So this is going to equal e to the power of 2x over ln absolute value x plus c to the power of 1/2. And that's going to be our final answer. Thank you for watching. Please be sure to like, share, and subscribe.